Molality. What is it and how do we use it to calculate quantities in chemistry? It is a type of solution concentration, not a qualitative but a quantitative method. And so like molarity, it's a certain ratio of a certain amount of solute to solvent or solute to solution. All chemistry is some kind of a ratio such as A equals B over C, where that represents your ratio. Molality specifically is the ratio of the number of moles of solute to the number of kilograms of solvent. Okay, so moles of solute per kilogram of solvent. Compare that to molarity, which we've already covered. There are really three differences between molality and molarity. You got the little m versus the big M, not a significant difference, but necessary. You have moles of solute and moles of solute, so that part's the same, but it's kilograms mass versus volume, and it's of the solvent, just the water, if it's an aqueous solution, versus the solution, which is both solute and solvent. Molality is used quite a bit in a temperature variable environment. That is because mass does not change with changes in temperature. You can increase temperature, you can decrease temperature. The grams or kilograms of the solvent is not going to change, but the volume will change. If you change temperature, the volume will expand or contract, and that is going to change molarity. So if it's used in something that's going to change temperature significantly, then molality is preferred over molarity. If I wanted to make a 0.50 molal solution of sodium chloride, so being a molal concentration, we want 0.5 moles of solute in 1 kilogram of solvent. So I would take the 0.50 moles of sodium chloride, mass out 1 kilograms worth of water, and then combine the two to make a 0.50 mole solution. We don't care that the volume changes. We don't care that the mass changes. I've got 0.5 moles of solute in 1 kilogram of solvent, so that is a 0.50 molal solution. In terms of equations with molality, if you are given this equation for molality and I ask you to solve for the number of moles, you can algebraically rearrange that equation to get the number of moles equals the kilograms times molality. And if you want to see how the units are expanded to get moles, here's my kilograms. Here is the molality, the ratio of moles to kilogram. Multiplying through, kilograms will cancel, giving you moles. To calculate for mass of solvent, now we want to solve for the kilograms, and rearranging that equation to solve for kilograms. Kilograms is going to equal the moles divided by the molality. And again, if you want to see how the units are going to give you the kilograms, let's expand units. So here we have our moles over molality. Moles and moles will cancel. That gives you 1 over kilograms, which equals kilograms. And then in terms of calculating the mass of the solute, it is going to equal the number of moles times the molar mass. But again, in molality problems, you're not going to be given the number of moles, but you know moles equals the kilograms times molality. And so substituting that in for moles, we get kilograms times molality times molar mass equals the grams. And again, if you want to see the units for this, here's my number of kilograms, here's the molality, kilograms then will cancel, here's the molar mass, moles will cancel, and that gives you the grams of the solute. Okay, do not confuse mass of solute with mass of solvent. They are two different quantities. Okay, going through a few sample problems. If I told you that a solution contains 0.20 moles of glucose and 250 grams of water, what is the molality of the solution? I just have to take the number of moles, divide by the number of kilograms. So the problem tells us we have 0.20 moles. We have 250 grams of water, divide by 1,000 to get kilograms. And so that comes out to a 0.80 mole concentration. Again, it's the number of moles of solute per kilogram of solvent. More typical problem is going to look like this. If we have 3.36 grams of urea in 155 grams of water, what is the molality of this solution? So now instead of given moles, we are given grams of solute and a certain grams of water. So remember, it's always the solute over the solvent. So the 3.36 is the grams of the solute. The 155 grams translates into 0.155 kilograms, and we have to take our grams, convert into moles to get moles over kilograms. So we divide by the molar mass of urea, that's CH4N2O, and that gives us a 0.361 mole concentration. So again, just got to get the number of moles divided by the number of kilograms. That is your molality. This one asks, how many grams of solvent? Key word here is grams of solvent. That is the bottom here. It's moles per kilogram of solvent. So in this problem, we're going to solve for kilograms of solvent, and then we can convert to moles. So algebraically rearranging this equation, we get the number of kilograms equals moles over molality. Substituting in, we have 10.5 grams of urea. We have to convert that to moles by dividing by the molar mass. Divide that by the molality will give us the number of kilograms. And then we were asked for grams of solvent, not kilograms of solvent. So multiply by 1,000 to convert the kilograms of water to grams of water. But again, watch the units and watch the labels. We're asked for solvent, not solute in this particular problem. This problem, we were asked for how many grams of urea, that is the solute. So now the number of grams equals the number of moles times the molar mass. This problem never gives you the moles, but it gives you the molality and the mass of water. So we can substitute in that for moles. Moles equals kilograms times molality. And so kilograms of water times the 1.5 mole concentration, which is moles per kilogram, times the molar mass of urea from the periodic table. Now moles will cancel, and that comes out to 36 grams.